Welcome once again to Izzo Math. Today we're going to be talking about the tangent function. We've already talked about the sine and cosine, and the tangent is pretty much an extension of that. So first of all, let's say we have some angle theta here, and we know that the coordinates are cosine theta, sine theta. That's the coordinates of that point, cosine theta, sine theta. Well, the tangent is simply the slope of that radius there. So here we have the x coordinate, so x equals the cosine theta, and we have our y coordinate. Here y is the sine theta. Our tangent function is simply defined as, it's always written as tan theta equals sine over cosine. Sine theta over cosine theta. And note, that is a rise over run. Rise, sine theta over run, cosine theta. So this is the slope of the radius at an angle of theta. For example, let's say that theta looks like it's about at somewhere close to pi over 3. So let's say this theta equals pi over 3. So the tangent of pi over 3 equals the slope, the rise over the run. So the sine of pi over 3 divided by the cosine of pi over 3. The sine of pi over 3 divided by the cosine of pi over 3. And so that's going to equal the sine of pi over 3 is going to be what? That's going to be root 3 over 2. And the cosine at pi over 3 is going to be this distance there. If you look at it, it looks like it's about at 1/2. So over 1/2 up root 3 over 2. So the tangent is the rise over the run. So it's going to be root 3 over 2 divided by 1/2, which equals, when you divide by a fraction, you flip and multiply. So root 3 over 2 times 2 over 1. 2's cancel each other, and we're going to get that equals root 3. So that is the tangent of pi over 3 is root 3. And more importantly, think of that as the slope. When we sketch the radius here with an angle of pi over 3 radians, the slope of this line is root 3. And let's get an approximation of root 3 just for fun. Root 3. So it's about 1.732, which is about 1.732. Okay? Let's look at another one. Let's say we want the tangent of pi over 4. Okay? So again, let's draw a circle here. So at pi over 4, we're right here, and that is, we have a cosine of root 2 over 2, and we have a sine of root 2 over 2. So the tangent of pi over 4 equals cosine, or sine, rise over run, sine of pi over 4 divided by the cosine of pi over 4, which equals root 2 over 2 divided by root 2 over 2, which equals 1. So the tangent of pi over 4 equals 1. That is the slope of this line. If you remember from your reading in the video, we found this using the line. This is the line y equals x. And we know that that thing has a slope of 1. So it should make sense that the tangent, if it is defined as the slope of that radius, we have theta equals pi over 4, that it equals 1. Okay? Let's try another one. Let's say the tangent of pi over 6. Okay? So, again, we need a circle. I'm getting pretty fast at drawing these. So, at pi over 6, we are about in there. So that's theta, which equals pi over 6. We know that our coordinates from previous work here, we know that our coordinates are root 3 over 2 and up 1/2. So that should have been a little more. Should have been about in there. Anyway, so we know we're at root 3 over 2 and up 1/2. So my tangent of pi over 6, so the tangent of pi over 6 equals the rise over the run. So the rise is my sine. Why does that keep switching on me? Sine of pi over 6 divided by the cosine of pi over 6, which equals the sine is 1/2 divided by the cosine is root 3 over 2, and so this is going to equal 1/2 times 2 over root 3. 2's cancel. We'll get 1 divided by square root of 3, and we want to rationalize this denominator. Just standard math data. I don't know what the real rationale is for it, but people have always not liked denominators that have radicals in them. So let's get the radical out of there, and we simply do that by multiplying by root 3 over root 3. Note that that is root 3 divided by root 3 is 1, so I've multiplied by 1, so that doesn't change anything. But the root 3 times root 3 on the bottom cancels out the radical, and I get a 3, and on top we get 1 times root 3, which is root 3. So the tangent of pi over 6 is root 3 over 3, and I want to get an approximation for that. Get my calculator out. So square root of 3 second square root 3 divided by 3 equals 0.577. So about 0.577. Okay? So let's sum this up. Let me draw a big circle here. Did I do a circle? There's a nice circle. So we got at let's see, here at pi over 6, we got that the tangent of theta equals at pi over 6, tangent of theta equals, what was it, root 3 over 3, which is about 0.577. 0.577. At, let's go with blue, at pi over 4, so tangent of theta, where theta was pi over 4, equaled 1. That was the line y equals x there. So we're at root 2 over 2, root 2 over 2 for my sine and cosine, so we got 1. And at go at pi over 3. When theta was pi over 3, we got the tangent of theta equaled, what was it, root 3, which equals, or which is about equal to, what was it, 1.7? Which one was it? About 1.732. So 1.732. And now that actually gives you the, if you get that and you understand that, you can get the tangent for all the angles on the standard unit circle. So for example, let's go at over here at when theta equals, so tangent of what, 1, 2, 3 pi over 4. It's the same as this one, except it's a negative 1. That is the line y equals a negative x. Okay. Let's say, for example, if we extend this green line here to there, we are at theta equals, so the tangent of what's that going to be? 1, 2, 3, 4, 5, 6, 7, 8 pi over 3. Is that right? So I mean 8 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 pi over 6, which is the tangent of what's that going to be? 2 goes into 8 4 times, 4 pi over 3. So the tangent of 4 pi over 3 is going to be, so it's on the same line here as when theta was pi over 3. So it has the same tangent value because it lies on the same line. And so that's going to be square root of 3. Let's say we are at, let's extend this line here. And so now we're at what? 1, 2, 3, 4, 5, 6, 7 pi over 6. So the tangent of 7 pi over 6. And I'm just counting around the unit circle in increments of pi over 6. So that's 1, 2, 3, 4, 5, 6, 7 pi over 6. And that gives me that we are at the tangent, so it's on the same line as that one, so it is root 3 over 3. So you can always get the tangents pretty easy. So let's say we have the tangent of, let me go in a different color here. So the tangent of 7, 8, 9, 7, 8, 9, 10. Let's say 11 pi over 6. So that is going to be 11 pi over 6 is going to be right in here. Alright, so it's going to be, if we look at this one here at pi over 6, it's going to be this, because my coordinates are the same, except one of them is negative. That is my x coordinate is the same. Here's the x coordinate. So the x coordinate is the same for both of them, but the y coordinate is the same, only it's negative for 11 pi over 6. So we're going to get that the tangent equals a negative root 3 over 3, which is about equal to 0.577. And again, you can plug in the x and y coordinates there and get that same value, but if we play it smart, we can just use the 3 that we found here. These 3, let me see our cuts. Yeah, so that one, and that one to get all of our standard angles. Let's see, how am I looking on time? Oh my goodness, I'm at 14 minutes, so we'll see if they'll let me. I'll see you in the next video. I don't know if they'll let me put this one on YouTube.